Hello everybody, welcome to Masaka Diocesan Examination Joint Mock 2026. Let's dive in and break out item 1. Before breaking down the item says that the leadership of Green Valley Community Water Project manages a solar-powered water distribution system that supplies clean water to households, schools, and small businesses. As the population grows, the management committee wants to determine whether the current system can continue meeting demand or whether investment in a larger storage tank and additional solar pumps is necessary. The committee recently introduced a computerized monitoring system to estimate daily water demand and forecast future consumption patterns. Available records indicates that when the community population was 1,500, 2,000, and 2,500 people, the average daily water consumption was 45k liters, 58k liters, and 71k liters, respectively. To assess the reliability of the computerized demand model, the committee will estimate the daily water consumption for a population of 1,800 people and determine the population corresponding to recorded daily consumption of 85k liters. The model will continue to be used if the estimated daily consumption of 1,800 people is less than 55k liters and the estimated population corresponding to 85k liters exceeds 3k people. Otherwise, the committee will review and adjust the model before using it for future planning and decision making. To assess the storage capacity of a proposed cylindrical water tank, engineers measured its radius as 2.85 meters and height as 5.40 meters. Due to limitations of the measuring equipment, the recorded dimensions may differ from the actual values by up to positive negative 0.05 meters in the radius of positive negative 0.08 meters in the height. Before constructions begin, the committee wishes to determine whether these measurements are sufficiently accurate for the intended design. The measurements will be accepted for constructions if the difference between the largest and smallest possible capacities of the tank based on the statement measurement areas does not exceed 10 meters cubed. Otherwise, dimensions will be remeasured using more precise equipment. As part of the routine assessment of the water supply system, engineers studied the inflow of water into the storage tank during the first 4 hours after sunrise. The flow rate was found to be described by F of T is equals to T over 4 plus T squared in the range of 0 less T less 4. Cubic meters per hour, where T represents the time in hours after sunrise, to estimate the total volume of water pumped into the tank during this period. The project engineer used a numerical approximation based on 5 equally spaced observations of the flow rate. The committee will accept the estimate for planning purposes if its deviation from the actual volume pumped does not exceed 3%. Otherwise, a more accurate method will be required before the estimate is used. The task is so precise and says that as a student of mathematics, analyze the available information and advise the committee with reasons on the reliability of the computerized demand model, the suitability of the proposed tank measurements for construction, and the accuracy of the estimated volume of water pumped into storage tank. Now, from the item 1, we are seeing Masaka Diocesan. It's trying to tell us the first problem from that item is find water use for 1,300 and 1,800 people. That one you're going to get it from interpolation. We're going to use interpolation, specifically linear, or you can use language interpolation. So methodology, computation, justification. That is so easy from linear interpolation. That is from the topic of interpolation. You can easily get it from there. Then item 2, we're going to the breakdown there. The specific part was find the population when the water is 85,000 liters. That one is inverse interpolation. Methodolize it, compute it, justify it to reach out to that. Then problem 3 from that item is check if the tank area is acceptable. So that one is specifically mensuration, volume of cylinder, area, maximum, minimum area. Methodology, volume is equals to pi r squared h. Yeah, you find the R mean, R max, H mean, H max, compute it, justify it to solve that problem. Problem 4 from that item, estimate volume pumped as the statement said so. Well, when do we to estimate the volume pumped? Well, that is from the topic of numerical integration, trapezium rule, Simpson's rule, exact integration plus percentage error, interpretation. There is volume is equals to you know how to do it, whereby your lower limit is 0, your upper limit is 4 from the function of t over 4 plus t squared as it's given there of the dt. Methodolize it, compute it. That is it. Check for accuracy. Of course, you're going to methodolize it, as I said, compute it, define the percentage error, and then justify it to solve that problem from that item 1. All of it is already broken down. Try it out, and we see how beautifully you'll come out with a solution. Thank you. Don't forget to share, subscribe.